Alright, number one for our Algebra 2 Semester 1 final review, find the slope and y-intercept of the equation. So I'm going to rewrite it here. 4y equals 3x plus 8. And I'm going to write it in slope-intercept form. So that means I want the y by itself. So I'm going to divide everything by 4. When you divide by 4, make sure you divide each and every term by 4. And so the 4's are going to go away, and I'm going to be left with y equals 3/4 x plus 2. And the reason I want it in slope-intercept form, y equals mx plus b, is because now I know the value of m, and so I know my slope is equal to 3/4, and I know the value of b, so I know my y-intercept is 2. Given the function f of x equals 2x squared minus 6, find each of the following. So what we're going to do here is we're going to take this function and we are going to replace the x with what's inside the parentheses. So I'm just going to rewrite this function a couple times. Alright, so my first one, I'm going to substitute in -2, second one 0, 3, and 4. Alright, so in the first one, I'm going to take care of the exponent first. So -2 squared is going to give me 4. And then 2 times 4 is going to give me 8. And then 8 minus 6 is going to give me 2. So f of -2 equals 2. Now we're going to do the same thing. Start with our exponent. 0 squared gives us 0. 2 times 0 gives us 0. And 0 minus 6 gives us -6. So my input is 0, my output is -6. 3 squared gives us 9. 2 times 9 is 18. 18 minus 6 is 12. So my input is 9. I'm sorry, my input is 3. My output is 12. And the last one, 4 squared, gives us 16. 2 times 16 gives us 32. 32 minus 6 gives us 26. So when my input is 4, my output is 26. Alright, number 3, simplify each of the following. So we have, we'll start with the first one. We need to take the 3 and distribute it in. So we get a 3x squared plus 3x. Now the 3 only multiplies by what's inside the parentheses. So now we're just going to rewrite the minus 4x squared plus 5x. So now we combine our like terms. We have an x squared, we have a 3x squared minus 4x squared, and so it gives us -x squared. And then we have a 3x plus 5x, so that gives us 8x. So that's our answer for the first one. Now the second one, we need to distribute the -1. And so the -1 is going to change the sign, so I get -x squared plus x, and then rewrite plus x squared minus 8x. So now as I combine my like terms, -x squared and a positive x squared are going to cancel out, so I don't need to write anything. And then I have 1x minus 8x gives me 7x. And the last one, take the negative 2 and distribute it in. So I get negative 2x squared minus 2x minus 7x squared plus 4x. Now combine like terms. A negative 2x squared minus 7x squared gives me a negative 9x squared. And then negative 2x plus 4x gives me a positive 2x. Alright, let's look at one more. Number 4, we're going to multiply these. So there's two ways you can multiply. You could just distribute everything, or if you wanted to, you could use the box method. Doesn't matter to me how you get your answer. So for the box method, you need to have 3, because this has 3 terms, and 2 rows, because this has 2 terms. So you put the x here, the positive 2 here, x squared plus 5x plus 4, and then now we multiply. So x times x squared gives me x cubed. X times 5x gives me 5x squared. X times 4 gives me 4x. Now we multiply the 2 by everything on top. So 2 times x squared gives me 2x squared. 2 times 5 gives me 10x. And 2 times 4 gives me 8. So now we're going to combine our like terms. So we're looking for anything that's like. So I have an x cubed, but no other x cubed. So it's going to just be x cubed by itself. So we took care of that box. So now we have an x squared, we have an x squared. So now we can combine these two. So 2x squared plus 5x squared gives me a 7x squared. Here we have an x and an x, so we can combine them. So 10x plus 4x gives me 14x. And then we're left with just that positive 8. All right, let's take a look at number 5. Find the slope and y-intercept of this equation. So like last time, we're going to take the equation and solve for y. So our first thing we need to do is move the 5x to the other side. So we get negative 3y equals negative 5x plus 6. Now we need to get rid of the negative 3, so we divide each and every term by negative 3. And so that gives us y equals a negative divided by a negative gives us a positive 5/3. And a positive divided by a negative gives us a negative. And 6 divided by 3 gives us 2. So our equation is now in slope-intercept form. So that means our slope, our m, is going to be a positive 5/3. And our y-intercept, our b, is going to be a negative 2. All right, number 6, true or false. We have the function g of x equals x minus 5 quantity squared, and we want to evaluate it when it's negative 2 and when it's 6, and see if when it's negative 2 if it's greater than when our input's 6. So I'm going to write the function twice. X minus 5 squared is going to be greater than the x minus 5 squared, and now I'm going to substitute in the negative 2 and 6, and we'll compare them to see which one's bigger. So this is negative 2 and this side is 6. So negative 2 minus 5 gives us negative 7 squared, and 6 minus 5 gives us 1 squared. And so negative 7 squared gives us 49, 1 squared gives us 1. So 49 is bigger than 1, so this is the correct symbol, so this would be true. Alright, number 7, state the standard form of the expression. So here we have this quantity subtracted by this quantity. And so when you have the minus outside the second parentheses, you can just like distribute the negative to all the terms, and basically it's just going to change all the signs in here. So this is going to become minus, minus, and then the plus. So it would be minus 5x cubed minus 3x squared, and then plus x. So now the first term, nothing happens, so we can just get rid of the parentheses. There's no number out front to change anything. So now we're just going to combine our like terms. So we have an x squared, but you see the x cubed, so that's our highest power. So we have a negative 5x cubed. And then we have the x squared with an x squared. So 4 minus 3 gives us a positive x squared. And then we have the negative 2x plus 1x gives us minus x. And then we have the constant 3, and there's no other constant, so it's just plus 3. So this is our final answer. Oh, it isn't the standard form part, means that our degrees are going to go down 3, 2, 1, none. That's why you always start by combining the highest degree first. All right, so we're going to simplify the expression. 5 rad 32 plus 2 rad 98. Right now there's nothing you can do, because in order to add the radicals, what's underneath has to be the same. And so we're going to break this down. And so when you break down the 32, 32 does break down to 4 times 8. But you always want to think about the biggest perfect square that goes into 32. And so it's actually better to use 16 times 2. So I'm going to do 16 times 2. And so now the square root of 16 we can do, it's going to come out as 4, and it's going to be 4 times 5. So 4 times 5 gives us 20. I can't take the square root of 2, so we just leave it. Now we're going to break down 98. So if you don't know what goes into 98, it's obviously even, so you can see what times 2 gives us 98. And when we do that, we actually get a nice number, 49. So 2 square root of 49 times 2. When I take the square root of 49, I get 7, so the 7 comes out, and that 7 is going to multiply by the 2 to give us 14 square root 2. And now we can combine our like terms. So we combine the 20 plus 14 to give us 34. And then rad, just like when you add 2x plus 3x, it stays x. You don't change what's underneath the square root. So it's just 34 rad 2. All right, number 9, state the vertex of the graph for each of the following. So the vertex is given as HK. So this is what we call vertex form. So remember that what we want to do is we want to find the value that makes what's inside the parentheses 0. So as you look at the first one, what would make x minus 1 0? And that'd be 1. And then the k is what comes after the parentheses, so that'd be minus 12. So we're going to do the same for the other 3. All right, what makes this 0? What minus 3 is 0? That'd be 3. What minus 5 is 0? 5. What minus 4 is 0? 4. Now the k is just what comes after the parentheses. So we're going to have 21, negative 2, negative 23. All right, for number 10, what is the domain and range of the function? So to find the domain, I like to imagine I have a vertical line here, and we just slide it across the x-axis, and we want to see when it touches the graph and when it doesn't. So remember that this is a parabola that opens up, and so it actually expands out. So right now, even though it doesn't look like it's touching the red, this would expand out and it would touch. And so is there any place where that vertical line and the red parabola would not touch? The answer is no, they always touch. So the domain for this function, the domain is all real numbers. Now for the range, we can do the same thing, but instead of doing the vertical line, we do the horizontal line, because that's what touches the y. And so right now you can see that that line's not touching the parabola, and so we want to find out where that first part it touches at. And the first part it touches is that when y is 1, and then it continues on and touches forever. So the first part it touches is at 1. So our range is going to be anytime y is greater than or equal to 1. So all numbers that are greater than or equal to 1. All right, number 11, what is the equation of a function that translate our parent function x squared left 4 units? So if we had our parent function, we want to know what moves the vertex right here 4 units to the left. So this would be our new graph. So our parent function is f of x equals x squared, and what would move that 4 to the left? And so it's inside the parentheses. And so a lot of times we might want to write minus 4, but remember, whatever inside the parentheses is counterintuitive, and it goes back to what makes the inside 0. So if it's negative 4 here, our vertex is at negative 4, 0. If I plug negative 4 in here, it doesn't make it 0. So this is actually x plus 4, because now negative 4 plus 4 is 0, and that's what I want. So this would be the function that moves the parent function 4 units to the left. All right, for number 12, the first thing you want to start off with is the vertex. So the vertex is right here. So the vertex is at negative 4, 3. And so we're going to write this in vertex form to start. And it is important to actually read the question, because it says we want it in standard form. So we're going to put this in vertex form first. So just like the last problem we talked about, this is going to be a x plus 4, because that negative 4 makes this 0. And then it gets shifted up 3, so this is plus 3 over here. Now, the one thing you really need to be careful of is this graph is opening down, so you got to make sure you come back over here and put a minus. That negative makes the graph go down. So now we need to expand that, x plus 4. So if you remember the shortcut, great. We square it, we multiply it, x times 4 is 4x, and we double it and get 8x. And then we square the last term. And now you got to make sure you keep all this inside the parentheses. Now we take this negative and we distribute it in, we change all the signs, and so that's going to give me a negative x squared minus 8x minus 16, and the 3 doesn't get multiplied by the negative because it's outside the parentheses. Now we combine these two, and so we end up with negative x squared minus 8x minus 13. And so you can call the function whatever you want, f of x. Okay, so now that you got your answer, a couple things to double check. Since the graph is going down, we want to make sure we have this minus. Another thing to look for is where is the graph touching the y-intercept. So it's going to be down here somewhere, and so this number here is our y-intercept, so it should make sense in the problem, and it does. This is negative 8, still not touching, so it's going to go down and probably touch at negative 13. So this is the correct answer. F of x equals negative x squared minus 8x minus 13. All right, number 13, write the equation of the parabola in a vertex form. So first thing you want to do is identify the vertex. So the vertex is at 6, 4, and so we're going to have our function. So this is the h value. This is the k value. So remember, the 6 is we're going to plug in here, and we want it to equal 0. So when I plug a 6 in, 6 minus 6 will give us that 0. So remember, inside the parentheses is counterintuitive. And then this plus 4 moves the graph up. So our function would be f of x equals quantity x minus 6 squared plus 4. Same type of problem, write the equation in vertex form. So we have f of x let's find our vertex first. So we have negative 1, negative 6. Probably the most important thing to notice right now is that the graph is going down, so we have to have a negative out front. And so when we plug this in, we're going to want this to be a plus 1, because negative 1 plus 1 gives us that 0 we're looking for. And then on the outside, that k would be minus 6. So since it says vertex form, we can leave our answer like this. All right, for 15, which shows the function below in order from widest to narrowest. So we want to know which functions are the widest and which ones are the narrowest. And so in our functions, the a value tells us whether it's going to be wide or narrow. So the bigger the number, so if this were 7x squared, that means the graph grows faster, and so that means that it's going to be narrow. And the smaller the number slows it down and makes the graph wider. So we want to figure out which one is the smallest number, and ignore the sign. We don't care about the sign right now. We just care about the number. And so 1/8 is smaller, so we're going to have w first. So we took care of this one. The next smallest number is 1/4. Next smallest number is 2, so it's going to be p. Next smallest number, which turns out to be the largest number, which is n. All right, for 16, find the vertex for each function. Which of the following functions has its vertex above the x-axis? So let's go ahead and draw a little graph. So this function, its vertex is at 4, 0. So imagine you come over here, 4, 0. This would be I, or the first one. Here, when there's no parentheses and there's no numbers, This is 0, 0. The next one, okay, so this would be 0, negative 8. 0, negative 8, somewhere down here. And then the last one, would be negative 3, positive 5. So negative 3 up 5. So which one has the vertex above the x-axis? So that would be 4. All right, for number 17, state the vertex. So we want to find the vertex, axis of symmetry. I also call this the line of symmetry, but y-intercept, and the max or min of the graph. All right, so it's not in vertex form, so you can't just look at it. You could put it in vertex form. So to put it in vertex form, we're going to practice completing the square again. All right, so what we're going to want to do is take out a negative, and we don't have to take out a negative from everything, just the negative x squared and the 8x. And so this plus 7 is still over here. And so now to complete the square, we take half of this. So that'd be 4. We square it, so it would be a 16. And then we would do that to both sides. Now, since this is a negative on the outside, it's really a negative 16. So to keep everything balanced, I'm actually just going to add a 16 to this side. So if you think about it just for half a second here, so this would be a negative 16 on this side. If I put a negative 16 on this side, then it's balanced. Well, I want everything on this side. That's why it stays as a positive 16. Or you can think of it as negative 16, again, negative because of this, and this positive 16 equals 0, so everything stays okay. So now this becomes negative x plus 4 squared plus 23. And so now what makes this 0? Negative 4. So it means my vertex is at negative 4, 23. So we have a negative 4, 23 as our vertex. So if you think about that, negative 4, 23 is up here as our vertex. The line of symmetry is the vertical line that goes through our vertex. And so our vertical line is going to be x equals negative 4. The y-intercept we know because of this is plus 7. So if you want, you could write it as a point, 0, 7. And so since this is a negative, our graph's going to be going down. So that makes this point the max. So we're going to have a max, and that's at the vertex, negative 4, 23. So the max value is 23 on the graph. It's at the point negative 4, 23. All right, 18, answer the following for each graph. So we'll start with this one. Is it increasing or decreasing? So as it goes up, as we go left to right. So it's increasing. The number of turns, so you can see it goes up, turns once, turns twice, so it has 2 turns. Identify the number of real zeros. So this is a pretty important concept that you're going to use over and over again. The zeros, the real zeros, are going to be where it touches the x-axis. So it touches once here, and one's here. So this has 3 real zeros. And then identify the in behavior. So as we go towards negative infinity, it's going down. As it's going to positive infinity, it goes up. Now as we look at the next one, here as we go left to right, the graph is going, eventually it goes down, so it's decreasing. The number of turns, so turns once here, comes down, turns goes back up, turns again, and so it looks like it has 3 turns. Touches the x-axis once, twice, so 2 times. And so now the in behavior, as we go to the left towards negative infinity, it goes down. As we go towards positive infinity, it's also going down. All right, so for this, we want to find the value of h and k. So we basically just want to put this in vertex form. So we have the x squared plus 6x plus 2. And so we're going to complete the square in this. So x squared plus 6x, move that 2 over, we don't need it right now. So what's half of 6? 3. And then we square it. 3 squared gives us 9. So when I add 9, to keep everything fair and balanced, I need to subtract 9. Since I'm not working across the equal sign, everything's staying on this side, we would need this and this to equal 0. So this factors to this, and then 2 minus 9 is going to give us negative 7. And so now it's in vertex form, so we know that the h is going to be negative 3, and the k is going to be negative 7. All right, number 20, write the equation of the parabola in vertex form. So our vertex is at negative 4, negative 6. So we've done enough of these now that hopefully you can just look at it. All right, so we want to figure out, so when I plug the negative 4 in, it makes it 0. So it's going to be the opposite, so it's going to be plus 4. And then that minus 6 will be on the outside here. So our vertex is at negative 4, negative 6, so plug the negative 4 in. That makes this 0. We're left with that minus 6, so now this is in vertex form. All right, 21. List all the graphs with an even degree. So an even degree will eventually have the in behavior going in the same direction. So here on A, we have it going positive as we go to the right, but negative as we go to the left. So that's an odd behavior. So B, so whenever the arrows are going in the same direction. C, D is opposite, E is same direction, they're both going down. F is opposite direction, G is opposite direction, and H, they're both going down. Now list all the graphs with a negative leading coefficient. So with a negative coefficient. So that means that I don't care if it's an even or an odd degree, it just ends going down. So A is going up, B is going up, C goes down, D is going down, E is going down, F is going down, G is going up, and H is going down. All right, for 3, write a possible equation for each graph, looking for something really generic, mainly just looking at the turns. So here, this graph has 2 turns. So probably going to end up being a cubic. So f of x equals something cubed. So you can just say that, or if you want to get fancy, 2x cubed plus x minus 1. It doesn't really matter. Here it looks like a parabola, so f of x, because it has one turn, so just some simple x squared minus 2. So now we have something with 1, 2, 3 turns. So if I had 3 turns, that means the degree is going to be 4. So again, something generic, but also you know how it's opening. So it's going down, so it would have to have a negative x to the 4th. And then after that, I really don't care too much. Plus x cubed minus x squared, blah, blah, blah. Doesn't matter. The main thing is the negative, and you have the x to the 4th. For D, how many turns? So 1, 2. So we know it's going to be something. 2 turns means it's going to have x to the 3rd. Or a possible equation. And then also notice that it's going down, so something negative. Notice that the y-intercept is below. Don't really care too much about that right now, but if you wanted to, you could say something like x squared minus 2. Number of turns, 1, 2, 3. So possible is going to be a power of 4. So f of x. Again, it's going down, so it has to have a negative x to the 4th minus 3x squared, whatever you want, plus x. And then you can see that the y-intercept is down here, maybe minus 4. F has 1, 2, 3, 4 turns. So now something like f of x equals x to the 5th. Now notice that it is going down, so a negative. Say plus x to the 4th minus x. And like I said, anything after x to the 5th really doesn't matter. It does have a positive y-intercept, so we'll call it plus 1. Here we have 1 turn, 2 turns. So f of x equals, it is going up, so you can just say x cubed plus x squared minus x. And here it looks like the y-intercept is somewhere up there around 5. Here we have this 1 turn. So it could be an x squared. So f of x equals, it's going down, so a negative x squared. Looks like it touches at 0. You see how wide it is, so again, we're looking really generic. Now, this isn't the only possible answer. It could also be f of x equals negative x to the 4th something. But this is the easiest, most generic answer, so that's probably what I would go with. Alright, number 22, name the roots of the following equations. So we're going to solve them. So the first one, negative 1/5 x squared equals 5. And so to get rid of the fraction, we're going to multiply both sides by the bottom number. And since this is a negative, I'm actually going to multiply by negative 5, because that'll get rid of the fraction in the negative. So when we do that, the negative goes away and the 5 goes away, and so now I'm just left with 1x squared, or just x squared, equals negative 25. And so now I need to get rid of the square, and so the opposite of squaring something is taking the square root. And so that gives me x equals, and so when we have the 25, that would be square root of 5 plus or minus, and so now we have the square root of that negative, because this really just breaks down to 25 times negative 1, and the square root of negative 1 is I. So the roots of this equation are plus or minus 5i. So let's take a look at the second problem. X squared minus 40 equals 9. So we're going to get x squared by itself, and we're going to add 40 to both sides. Now the reason I'm not minusing the 9 and I'm going to try to factor it that way is because there's no x value. We have an x squared but no x. And so when that happens, we can just solve it like a normal equation just by undoing the operations. So now I have x squared equals 49, and so we square root both sides. And so I end up with x equals The square root of 49 is plus or minus 7. Alright, the third one, we have 1/3 x squared equals 12. Like before, we're going to get rid of the fraction by multiplying both sides by 3. And so they cancel out, and I get x squared equals 36. Now square root both sides. And we have x equals plus or minus 6. And the last problem, 20 plus x squared equals negative 16. Need to get the x squared by itself, so we minus 20 from both sides. And so we end up with x squared equals negative 36. Square root. And so like before, since we have that negative, we know that we're going to have the square root of 36 and also the square root of I, so we get plus or minus 6i. So we have our 4 answers. Alright, 23, what information does the discriminant provide? And so in the quadratic formula, we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the discriminant is the b squared minus 4ac. It's what's underneath the radical. And so what happens is, if we look at our quadratic formula, and I evaluate the discriminant, the b squared minus 4ac, and I get a positive answer, then that means I can actually square root it and keep working. And I'll end up with 2 answers. If I get 0, then the square root of 0 is just 0, and so it doesn't matter if I add 0 or minus 0, it's still going to be the same. So I'm going to end up with 1 answer, or 1 solution. Here, when it was positive, I had 2 solutions. And now if I have a discriminant that's negative, back in algebra we would say no solutions. Well, now in algebra 2 we say no real solutions, because we know we can have an imaginary solution, but we say no real solution. So on the graph, the 2 solution touches the graph twice. So you might have a parabola that opens up and touches the graph twice. When it's 1 solution, the graph only touches once. And that happens when the vertex is on the x-axis. And then when we have no real solution is when we'll have a parabola that opens up or down with the vertex is above the x-axis or below the x-axis. So the discriminant doesn't tell us the minimum or the maximum value. It tells us the number of zeros. Alright, for 24, find the solutions. So we have x minus 2 squared equals 36. And so what we want to do here is we want to undo that square. So we're going to square root both sides. And so now we have x minus 2 equals, and remember the square root of 36 is going to give us a positive 6, but also a negative 6. And so now when I add 2 to both sides, I need to make sure I include it with the other 6. And so we end up with x equals 8, and negative 6 plus 2 is negative 4. So whenever you're have a problem with an equal sign and you're solving, you get an answer, take that answer and plug it in, make sure it works. 8 minus 2 is 6, 6 squared is 36. Take the negative 4, negative 4 minus 2 is negative 6, negative 6 squared equals 36. Alright, 25, which number should be added to make a perfect square trinomial for each of the following? And so this is basically the first step when we complete the square. So what we do is we take this middle term and divide by 2. So 12 divided by 2 is 6. And then we take our answer and we square it. So we take the middle term, divide by 2, and square. That's what we're going to add to both sides. So b, the middle term divided by 2, squared. So what's half of 12? 6. 6 squared is 36. Half of 16 is 8. 8 squared is 64. Now, even with the negative, half of negative 20 is negative 10, but when we square a negative times a negative is a positive, it's always going to be adding here. So the negative 10 squared gives us a positive 100. And the last one, half of 28 is 14, and so 14 times 14 gives us 196. So just ask for what we're going to add, so our answer would be what you see here. Alright, 26, find the zeros of each function. So hopefully by now you can look at this and factor it. If you can't, you can always draw the x. 1 times negative 8 is negative 8, and they have to add to 2. So what number is multiplied at negative 8 but add to 2? And that would be positive 4 and negative 2. So now we want to find the zeros, so we make it equal 0. So what would make this 0? Negative 4. And what would make this 0? Positive 2. Alright, so now if we're going to find the zeros in this one, the first thing we want to do is we want to take out the GCF, and you might look at it and say, well, it doesn't have a GCF. If we're going to use this magic x, you always want to make sure that the coefficient is positive. So what we're going to do is we are going to take out a negative 1. So the negative 1 turns into x squared plus 2x minus 8. And so now hopefully you realize that this and this are the same. So if they're the same, they're going to have the same zeros. So x equals negative 4 and 2. Like before, take out the GCF. So you take out a 2, and we get x squared plus 2x minus 8. Once again, that repeats. And so it's going to have the same zeros. So we get x equals a negative 4 and 2. So the point of this question is for you to realize that even though the functions look different, I mean this one's positive, this one's negative, this one's going to be narrower, they can still have the same zeros. Alright, number 27, what does a positive discriminant tell us? So we just talked about that. So when our b squared minus 4ac is positive, when it's greater than 0, that tells us we have 2 real solutions. What does a 0 tell us? So when our discriminant b squared minus 4ac is equal to 0, that tells us that we have 1 real solution. And then when our discriminant's negative, b squared minus 4ac. When it's negative, it would be less than 0. That tells us we have 0 real solutions. So the graph does not touch the x-intercept. So it would be a graph either above or below the x-axis. Alright, for 28 we want to find a discriminant, so we want to make sure that the equation is in standard form, and so when we have a quadratic we want to make it equal 0. So we're going to minus 12 from both sides. And so we end up with a 3x squared minus a 7x minus 12 equals 0. And so the discriminant is b squared minus 4ac, so we need to know our a, b, and c values. So we have our a is 3, b is negative 7, and c is negative 12. So now we just substitute them in and evaluate it. So b is going to be negative 7. Our a value is going to be 3. And our c value is going to be negative 12. Okay, so now we just simplify. So negative 7 squared gives us 49. And what I like to do is multiply the parentheses, so it's going to give me a negative 36. And so now we treat this like a negative 4 times negative 36 is going to give me 144 positive. And so now we add them together, and that gives me 193. So my discriminant is 193. So if the question asks how many solutions does it have, this one would have 2 real solutions because our answer. Alright, 29, state the zeros for the following functions. So you can go ahead and just make these things equal 0. And so with the first one, this is actually one that students actually miss a lot because they don't know what to do with that x. Basically you split these two things apart and you make them equal 0. So x equals 0 and also x minus 9 equals 0. And so there's nothing you can do here. X just equals 0. Here x would be 9. So our answers are 0 and 9. If you think about this, if this x were 0, this 0 would make whatever is in here also 0. So 0 times whatever would still give us that 0. So what's inside what number minus 2 equals 0? X equals 2. Here we'd have two answers, x equals negative 2 and negative 4. And here we'd have just that one answer, x equals negative 6. Alright, for 30, find the zeros of x squared plus 10x plus 29. So x squared plus 10x plus 29. And so your first thing you'd probably want to try is you'd probably want to try to factor this. And so we can get x times x that equal x squared. But now the 29, what numbers multiply to 29? And 29 is prime, so it would have to be plus 29 plus 1. And those numbers will not add to 10. So factoring doesn't work. And so factoring doesn't work, then you have a couple different choices. You could complete the square, or you could use the quadratic formula. Now since this middle term is even, I'm going to choose to complete the square. Also, since this is a 1 in front, it's another good problem to complete the square on. So let's move that 29 the other side. And so now we get x squared plus 10x, leave a blank, equals negative 29. And so what you can also do is start the next step. We know this is going to be an x. We know this is going to be squared. So now take half of the middle. Well, that half of that is going to go right here. So we know this is going to be x plus 5. And then the half of that 5 is going to be squared. And that's what goes here. So x squared plus 10x plus 25 is now a perfect square trinomial. So we added 25 on that side, so now we got to add 25 on this side. So that gives us negative 29 plus 25 is negative 4. Now we just need to get rid of that square. So we square root both sides. Now I get x plus 5 equals plus or minus the square root of 4 is 2. The square root of the negative is going to give us an I. So we get plus or minus 2i. Now last step, minus 5 over. And we get x equals negative 5 plus or minus 2i. So these are the zeros for the given function. Alright, 31, find the zeros for the following functions. So let's go ahead and write this as x squared plus 6x plus 11 equals 0. And so if you want, you could try to factor it, try to figure out what numbers multiply to 11, but are going to add to 6. And since 11's prime, you're not going to be able to get 11 and 1 to 6, so you can't factor it. So that doesn't work. So now, since this is a 1 in front, since this is an even, I'm going to complete the square. So I'm going to minus the 11 to both sides. So we get x squared plus 6x equals negative 11. And so I like to start the next step, x squared. Alright, so take half of 6. It's going to go here. 3 squared is going to go here. And so we have to do it to both sides. And so now this perfect square trinomial would factor to x plus 3 quantity squared. And so we have negative 11 plus 9 gives us negative 2. Now the whole reason we want to complete the square is so we can do the next step, so that we can then square root both sides, because now I can square root that square and they cancel each other out, and I'm left with an x plus 3 equals, now I can't square root 2, but I can take out the negative, that negative 1, and have plus or minus I rad 2. Now minus 3 to both sides. And we're left with x equals negative 3 plus or minus I rad 2. Alright, so let's see here. Can we factor this? What numbers multiply to negative 3 but add to 4? So since they're going to multiply to a negative, that means one has to be positive, one has to be negative. And so since it's 3, I can have 3 and 1, but 3 plus negative 1 won't equal 4. So this is another example where I can't factor. It feels like I can factor it, but when you actually work it out, it doesn't work. Because you want the 3 and 1 to work, but it doesn't work with the signs. Alright, so I'm going to complete the square in this one, again, because it has an even middle term, has a 1 in front. So let's go ahead and add the 3 over. So this would be a good time to complete the problem on your own, if you haven't already done so, so you can actually just check your work to see if you're doing it right. So we're going to have the x squared plus 4x, leave a blank, equals 3. And then go ahead and start the next step. Alright, so take half of 4, which is a positive 2. 2 squared gives us 4. So now we have 4 to both sides. 3 plus 4 gives us that 7. And so now we can square root this. So the square root cancels out the square, and I'm left with x plus 2 equals a plus or minus rad 7. Now we just got to move the 2 over. We minus 2 to both sides. And we have x equals negative 2 plus or minus rad 7. Alright, the last one. You can try to factor it if you like, but since 17 is prime, you're not going to get 17 and 1 to negative 8. So we're going to complete the square in this one also. So x squared minus 8x plus 17 equals 0. So minus is 17 from both sides. And I get x squared minus 8x equals negative 17. Start the next step. So what's half of a negative 8? It'd be negative 4. Negative 4 squared is positive 16. So we're going to add 16 to both sides. So negative 17 plus 16 is negative 1. Now we're going to square root both sides to get rid of the square. And now we have x minus 4 equals the square root of negative 1 is I. Now we can add 4 to both sides. And we're left with x equals 4 plus or minus I. All right, for 32, what is the complex conjugate of each of the following? So the complex conjugate is going to, the first number stays the same, and the second we take the opposite. So the 3 stays the same, and the opposite of positive I is just a minus I. So the complex conjugate of 3 plus I is 3 minus I. Here, the negative 5, the real part stays the same, and the imaginary part, just take the opposite. So it would stay negative 5, and the opposite of a negative I would be plus I. So let's add one more example. Let's do 2 minus 7i. So the real part stays the same. And then we take the opposite of the imaginary. So the opposite of negative 7i would be plus 7i. Alright, for number 20 we're going to simplify. And you could multiply the 20 in as your first step, but I'm not going to do that because I want to keep the numbers small. And so now here's an example where we'd use the complex conjugate. This will get rid of the imaginary number in the denominator. So we're going to multiply top and bottom by 3 minus I. So let's see here. I'm going to leave that 20 where it is. And so 7 times 3 gives me 21. 7 times negative I gives me minus 7i. And now the negative 2 times 3 gives me negative 6i. And then the negative 2 times the negative I gives me a positive 2i squared. And so now on the bottom, so instead of distributing this one, I'll use the box method as review. So we have a 3 plus I, a 3 a minus I. So the 3 and 3 makes 9 plus 3i minus 3i minus I squared. So now combine your like terms. So now I'm going to have 9. These are opposites, so they're going to go away. Minus I squared. Alright, we can clean up this a little bit here. Now remember that I squared equals negative 1. So this is going to be 2 times negative 1. So this is actually going to become negative 2. So it's going to be 20. And then this 21 minus 2 gives us 19. And now combine the negative 7i with the negative 6i for a negative 13i. And then like up here, this I squared is going to become a negative 1. And so this negative negative is going to actually turn into a plus 1. So this is going to become 9 plus 1, which is just 10. So now we can reduce our fraction. 10 is going to go in the 20 2 times. And so I'm left with 2 times 19 minus 13i. So if this isn't one of the possible answers, you could try multiplying the 2 in, but more than likely this will be the answer because we want it in simplest form, so we'll factor out the GCF. Alright, 34, what is a conjugate, or what's a complex conjugate? So like we already talked about, the real number stays the same, so it's going to be 9, and then we take the opposite of the imaginary part, 9 minus 7i. Alright, what value of c makes the equation true? So I want to, let's just go ahead and rewrite the left side and simplify and see what happens. So I'm going to want to distribute the negative 3 in. And so I get 5 minus 6i, negative 3 times negative 4 is plus 12. Now combine your like terms, so 5 and 12 makes 17 minus 6i. And so now I'll go back to the question, because there's nothing else I can do here. We want to know, so the left side simplified to this, and the right side given was 17 plus ci. So c is just a unknown. Well, now we know what it is. So c would be negative 6. Uh, 36, right? The polynomial function with the 0, 0, 3, 2i, and a negative 2i. So these are our solutions, our zeros. And so what we can do to get our factors, if we write them all out, x equals 0, x equals negative 3, x equals 2i, and x equals negative 2i, and then we undo it, well, there's nothing I can undo here, just x. But here, if I add 3 to both sides, we get x plus 3 equals 0. And so that kind of shows why negative 3 is our 0. Now this is the factor we're going to use. And so you can kind of see what's going to happen over here. We're going to minus 2i, and we're going to have a factor of x minus 2i. Here we'll add 2i and get a factor of x plus 2i. And so we want to put all this together. So we have the x plus 3. We have the x minus 2i. The x plus 2i. And then we have this 0. Well, that's just x. So go ahead and when you simplify this, you'd want to simplify the imaginary first because you should notice that this is a complex conjugate. So as you multiply these, if you want to do the box method, that's fine, but x and x is going to make x squared. X and 2i is going to give us positive 2i. Negative 2 and 2i and x is going to give us a negative. I forgot the x there, so 2xi. So now we're going to have a negative 2xi, then a negative 2i plus 2i, or multiplied by 2i gives us a negative 4i squared. And so these are opposites, so they're going to go away. And remember, I squared is negative 1, so this here is going to become a positive 4. And so this multiplies to x squared plus 4. Here we can multiply these together and get x squared plus 3x. I just went x times x and got x squared, x times 3 and got 3x. And so now let's review the box method to multiply these two things together. So I have two terms and two terms, so 2 on top, 2 on the side. So x squared and 3x, x squared, 4. So now I'll multiply them together. X squared and x squared makes x to the 4th. X squared times 3x gives us 3x cubed. 4 times x squared gives us 4x squared. And then 4 times 3x gives us 12x. So you'll notice there's no common terms, so we're just going to rewrite it. So our function is going to be x to the 4th plus 3x cubed plus 4x squared plus 12x. And so finally at 37 we have the negative 3 plus 7i squared, which is just negative 3 plus 7i times negative 3 plus 7i. So you can distribute this out. You can do the box method. Doesn't really matter. That's going to give us a positive 9, negative 21i, negative 21i, positive 49i squared. Now, since these aren't complex conjugates, you're going to still have that middle term with just the I. So now we combine, and so the negative 21i and negative 21i is going to give us negative 42i. The I squared becomes negative 1, and so negative 1 times 49, this whole thing becomes negative 49. So negative 49 and 9 gives us negative 40. Now, if you remember my shortcut, we square. So negative 3 squared is 9. We multiply and double. So negative 3 times 7 is negative 21 doubled is negative 42i, and then we square. So that gives us positive 49i squared. Same thing, this becomes negative 1, this becomes negative 49, 9 and negative 49 gives us negative 40 minus 42i. It's great if you remember the shortcut, but if you don't, you can always just expand it and multiply it out. All right, for 38, write the first 6 rows of Pascal's triangle. So we start with 1, and then we expand out. And so you really just need to memorize that the outer edges of the triangle are always 1, and that the inside numbers come from the prior top 2 numbers. So here what happens is the outer edge of the triangle is 1, and then these 2 ones add to give us 2. Same thing, the outer edge is 1. But now we have 1 and 2 makes 3. And the same thing happens on this side. 1 and 2 makes 3. Outer edge is 1. And now the inner numbers. So we're going to have 1 and 3, 3 and 3, 3 and 1. So we have 4, 6, 4. Outer edge is 1. One and 4 is going to make 5, 10, 6 and 4, 10, 4 and 1, 5. Alright, so for 6 rows, I got 5 so far. Outer edge is 1. So this is going to give us 6, 15, 20, 15, 6. Alright, so now we have the first 6 rows, and so now we're going to use the rows to do number 39, simplify the polynomial x plus 3 to the 4th. So the one thing you have to remember is that these correspond to the power, and so we have to start with 0. So like this, where there's 0 power, first power, second power, third power, fourth power. So this is the row I'm going to use because of the 4. Alright, so write the coefficients, the 1, 4, 6, 4, 1. And so now we'll work with the first term. And so I just like to put the open set of parentheses underneath the coefficients. And then we're going to start with the power of 4 and work our way down. 4, 3, 2, 1, none. And so the first term is just x, so these are all going to be x. And so then we're going to set up the next row. Same thing, just an open set of parentheses. So now for the exponent on this one, it goes in reverse. So we're going to start at 0, 1, 2, 3, 4. And we'll plug in the 3. All right, and so now we'll set it up. And so let's just separate these. All right. So x to the 4th is just x to the 4th, so we took care of that. 3 to the 0 is just 1. X to the 3rd is just x to the 3rd. 3 to the power of 1 is just 3. x squared. 3 squared is 9. X to the power of 1 is just x. The 3 cubed is 27. This becomes 1. 3 to the 4th is 81. So now you just multiply the 1, the x to the 4th, times the 1, which gives us x to the 4th. Just multiply 4 times x cubed times 3. So 4 times 3 gives us 12. So it's going to be a positive 12x to the third. So now do 6 times 9 is 54, x squared. Four times 27 times x give us 108, and then 1 times 1 times 81. All right, number 40, what is the degree of the polynomial function? You really got to be careful because this is going to be a multiple choice test. And I guarantee you one of the possible answers is going to be 3. And you might think 3 because of this, but you have to remember the degree is the highest exponent. So it's going to be 5. So the degree of this function is 5. All right, what is the remainder? When we take this function and divide it by x plus 5. So we're going to use synthetic division, and when you use the synthetic division, you want to make sure you set this equal to 0. So what value of x makes this 0? And so that'd be negative 5. And so now we just take the coefficients, and we also want to make sure that we have all the it goes cubed, squared, 1, none, so we're good there. So that's going to be 1, 4, negative 8, negative 9. So now we just bring the 1 down. And so now you multiply 1 times negative 5. And then we add 4 plus negative 5 is negative 1. And then we repeat negative 1 times negative 5 is positive 5. Now you add negative 3. Now you multiply negative 3 times negative 5. Now you add. And so this number here at the end is my remainder. And so my remainder is 6. All right, for 42 it says, which of the following is not a factor? And so we can actually figure this one out 2 ways. The easiest way, I think, is to use synthetic division. And so we'll start with this one. So what's the opposite of the 2? Gives us a negative 2. That's what makes that 0. And so now it goes 3, 2, 1, none, so we're good there. So now just write the coefficients. And so if it's a factor, our remainder here is going to be 1. I'm sorry, it's going to be 0. If it's not a factor, then we'll actually have some number here. All right, so bring the 6 down. 6 times negative 2 gives us negative 12. Add gives us 1. Negative 2. 1 plus negative 2 is negative 1. Negative 1 times negative 2 gives us a positive 2. And negative 2 plus 2 is 0. So since we get this 0, that means that x plus 2 is a factor. So it says which of the following is not a factor. Well, we don't know yet, so we're actually going to figure it out. But the other way, instead of doing synthetic division, is you can actually take what makes this 0, 4, so just like that first step there, but you could actually take that and plug it in. And so you could go 6 times 4 cubed plus 13 times 4 squared plus 4 minus 2. Now, I wouldn't do it for this problem simply because the numbers are ones that I'm not going to be able to do in my head. But 4 to the third is 64. And so this becomes 6 times 64 plus 13 times 16 plus 4 minus 2. And so 6 times 64 gives us 384 plus 13 times 16 gives us 208 plus 4 minus 2. So now we just work that out. 384 plus 208 plus 4 minus 2 gives us a 594. So if it were a factor, that would mean that 4 would be a 0, and so we would want 0 here. So this one is not 0, so this is not a factor. So this one is not a factor. So if you wanted to use synthetic division, you'd have the 4 on the outside, use the coefficients 6, 13, 1, negative 2. And it would look like this. So you still get some ugly numbers, but not that big a deal. The main thing is that you see the 594 and 594 are the same. So again, the x minus 4 is not a factor. Alright, so for 43, we're going to see which one is a factor of this. I'm going to use synthetic division again. So set up the coefficients. 1, 9, 10, negative 24. Bring down the 1. And so 1 times negative 3 is negative 3. 9 plus negative 3 is 6. 6 times negative 3 is negative 18. 10 plus negative 18 is negative 8. And negative 8 times negative 3 is 24. And so negative 24 plus 24 is 0. So since we have a 0 here, that means that x plus 3 is a factor. So I know the answer is x plus 3. But it can also be this. And this is not necessarily a multiple choice question the way this is written. So now let's take this and plug a 3 here. And then the same coefficients. Bring the 1 down. So 1 times 3 gives us 3. 3 plus 9 is 12. 12 times 3 is 36. 10 plus 36 is 46. And 46 times 3 is 138. And then 138 plus negative 24 is 114. So since our remainder is 114, this means that not a 0, which means it's not a factor. And so the first one is our answer. All right, number 44, which values of x is the expression undefined? And so here, the undefined, what makes an expression undefined is if we have a 0 on the bottom, because we cannot divide by a 0. So what you need to do is factor the bottom, and so we're going to have what numbers multiply to negative 18, and that are going to add to positive 3. So that's going to be a positive 6 and a negative 3. And so what makes this 0? And what makes this 0? So the values that make it undefined are negative 6 and positive 3. So now, at what point does this graph have a hole? So you're going to want to factor the top. And so, let's see here. When numbers multiply to negative 12, but add to a negative 11, and so that would be negative 12 and a positive 1. And remember, since we have this 4 here, we have to divide by 4, and then we have to reduce our fraction. And so this becomes negative 3 over 1. And so now the bottom number is my leading coefficient. And so this becomes 1x minus 3. And this is going to be my 4x plus 1. So just do a quick little check. X times 4x gives us the 4x squared. And negative 3 times 1 gives us that negative 3. And so these will give us negative 12. This will give us a positive 1, so it does work out. Alright, so now we see that the x minus 3 and the x minus 3 are going to cancel. And so this function simplifies to 4x plus 1. And so now to figure out where the hole is at, you go back to the term we crossed out. And so what would make this 0? And so that would be 3. And so what we're going to do is, since it's a point, we know it's going to be 3 comma something. So that gives us our x value of the hole. And so now you take the 3 and just plug it in. And so 4 times 3 plus 1, 12 plus 1 is 13. Alright, so we're going to simplify. And so what I like to do is reduce this first. So I'm going to have the 6 and 8. The 6 and 8 are going to reduce to a 3 over 4. And so now you look at the x's. Well, where do you have more x's, on top or on bottom? So since you have them on top, that's where your answer is going to go. And now you just subtract. 4 minus 3 gives me 1. Where do you have more y's, on top or bottom? So I have more y's on the bottom. And now you subtract. 5 minus 2 gives me 3. And so now we'll simplify this before we take care of the division. So 2 over 12 becomes 1/6. The x over x just cancels away, so we don't have to worry about it. And there's nothing to change the y, so it's going to stay y squared. So now both fractions are completely simplified. So now we're going to multiply by the reciprocal, and so it's going to be 6y squared over 1. And so now I'm just going to multiply across. I know that I could reduce the 6 and the 4, but I'm just going to go straight across and get 18y squared over 4xy cubed. And I just like having everything lined up. So now I can reduce. 18 over 4 reduces to 9/2. There's nothing to cancel out the x, so the x stays on the bottom. Where do you have more y's? On the bottom. So 3 minus 2 gives me 1. So this expression turns into this. Simplify each of the following, then circle the equivalent or the equal expressions. Alright, so the first one, we have x minus 4, x plus 2, x plus 2. So the x plus 2's cancel out, and I'm left with x minus 4. Here, when we're adding, we got to have the same denominator. So the x minus 4 and x minus 4 are the same. So I have a common denominator. Now I'm going to add the top. 1x plus 1x gives me 2x. 2 plus 2 gives me 4. And then I'm going to want to factor the top to see if anything is going to cancel. And so nothing cancels there. And so now on the bottom, the last one, we have x minus 8 canceling. We have x plus 4 canceling. And so now the only thing that is left is x minus 4. So now I will circle the equivalent expressions. All right, 49. So we're going to add these. And in order to add them, we got to have common denominators, which we do. So the denominator is not going to change. It's going to be 5x squared. And then 7 plus 9 is 16. Nothing reduces, so that's my answer.